Hey everyone, we are going to do the last two examples for our unit on curve sketching. So let's just pull up some information here, and we want to justify all of our results with what we learned in this chapter. So the last thing we talked about was an odd or even function, and this is an odd function because it's x cubed plus x to the 1. So no, it's an odd function, so it should be symmetry to the origin, symmetry to 0, 0. Regions of increase and decrease, we're just going to talk about where our slopes are 0. This function, x cubed plus x, it's a polynomial function. There's no divide by 0. There's no square roots and negatives. So it has a domain of all real numbers. So we just want to find where the slope equals 0 to find some critical numbers. Regions of concavity, so we're going to find a second derivative. Again, find some critical numbers for our second derivative. And then based on that, hopefully find some points of inflection. And then we want to talk about what's happening at infinity. Do we have asymptotes at infinity, or are we going to infinity? The fact that this is not dividing by 0 means we're not going to have a horizontal asymptote or vertical asymptote. So we want to figure out if we're going to positive infinity or negative infinity. All right, so let's go back and right from the very start. Find your slope equals 0, find some critical numbers. Your derivative is 3x squared plus 1. Well, 3x squared plus 1 is never 0, and it's never negative. So you have from negative infinity to infinity, your slope is always positive, which means your function's always increasing. Right? So there is no local maximum, no local minimum. It doesn't matter what you put in here. When you square it and add 1 to it, you're always going to be positive. So that's the first thing we look at, is it's always increasing. Our second derivative then, so derivative of 3x squared is 6x. 6x has a 0 when x is 0. So now we've got a region from negative infinity to 0, 0 to infinity. I don't need the 6, but you can put the 6 in. It's just the x is the factor that determines whether you're concave up or concave down. Some of these questions where it's simple, you don't really need to do the table, but it's sometimes it's nice to review the table in terms of how it works. If I put a negative number in, my concavity is negative, which means I'm concave down, and I've got positive is positive and concave up. So f of 0 then becomes a point of inflection. I'm changing from concave down to concave up, concave down to concave up. I've got a point of inflection. So I got 0 in here. If I put 0 back in my original function, remember, I don't want to put it in my slope. I don't want to put in my second derivative. To find my point, I got to put 0 in to my function. And look at that, 0 is 0, which matches it being an odd function, right? Because we said it's going to be symmetry about the origin. So 0, 0 is a point there. Now what happens at infinity? What happens at infinity? Well, we can't go infinity plus infinity. So we use our factoring skills, take out the largest degree, take out x cubed, allows me to put my infinities in now, infinity cubed, and then 1 plus 0, so I get infinity. So as my x value gets larger, my graph is going to be going up to the right. That also matches the idea of my slope, right? My slope is always positive, which means my function is always increasing. So as x get larger, the y's get larger. Everything's matching. So if I take all that information, I used a graphing app, obviously, and I can plot some points, right? So here again, I have 1 with 2, -1, -2, 3 with 10, -3, -10. So again, that's symmetry about the origin matches. My function is increasing the entire time. That matches my first derivative. This left-hand side is concave down. So if you were to draw the tangent lines, you're above the function all the way. At 0, 0, now I got a little wiggle in my graph here. It doesn't hit a top and come back down though, right? Because that would mean that I went from increasing to decreasing. It's just a wiggle, and then my tangent lines are now underneath. So if you're going to sketch this graph on your own by hand, you'd want to make sure you don't actually have it go up and then come back down at this point. It just has to always be increasing, always increasing. So don't go up and come back down. So that's example number 1A. That's using all of our properties right from the start of the chapter, talking about slopes, talking about derivatives, and then talking about odd, even, and asymptotes. We'll do another example with B here right away.